Okay, so both these problems are checking whether you can do implicit differentiation. So let's see. So here is, they're saying, bam, I want the second derivative at a point when I know the rule for the first derivative. So we're going to take the derivative with respect to x, because that's the bottom variable, of dy dx is worth, and you're like, bam, product rule. Next time I have to leave school in a hurry, I'm going to remember my sound machine. I forgot it at school, but you got to remember the product rule. So you're like, you need a derivative and a regular function. So we're going to take the derivative of the first function, which is x, times it by the plain second function, and then reverse it. Okay, now we got to be careful. The derivative of x is 1. No multiplier required because the x matches the x, times by y. When we do this one, the derivative of y is 1, but the x doesn't match the y, so chain rules in play. We need dy dx times x. Okay, so since we're doing it at a point, let's just find, you could either swap out dy dx here, but I'm going to go and just figure out what it is. They say when x is 2, because that's the x, when y is 3. That would be the x number times the y number, which is 6. Okay, so now I'm just going to find it's d squared y dx squared at x equals 2, y equals 3 is 1 times the y number, which is 3, plus 1 times the first derivative at that point, which is 6, times the x number, which is 2. I think that's 15. Okay, now the second problem is the same idea, except you want to know something in an instant. So that means we want to differentiate with respect to time, which is not in this equation. This equation does not depend on time. So we're like, bam, we're going to have to do implicit differentiation again. So let's look to see what the different information they gave us. They gave us the radius is changing. So you're like, this is not a two algebra problem. This is a calculus problem. This is dr dt is plus 2. And the height is increasing by 3. So dh dt is 3. At the instant when the radius is 10, so that's just like a regular variable we had before this year, and the height is 20. Okay, what do they want us to find? How fast is the volume changing? Oh, so we need a rate. We need dv dt. Okay, so what would dv dt be? It would be the derivative with respect to t of how you calculate the volume, which is pi r squared times h. So I'm going to think of this as the first function and this is the second, and I need product rule again. Okay, let's make our template. Okay, the derivative of that would be pi times 2, so 2 pi r to the first. R doesn't match t, so you need dr dt. Don't forget to bring down the h. Same thing again. The derivative of h is 1. But the h doesn't match the t, so chain rules in play. Bring down the next group. It's super easy to sort of miss plugging in something, so sometimes it's nice just to like make some parentheses for what you're going to drop in. I don't need the 1 anymore. Okay, so let's see. So we need r. R is 10. We need dr dt, that's 2. We need h is 20. Then we need dh dt, that's 3. I've got my 2, I've got my pi, the r is 10, I have to square it. So I think that's 4 times 200, I think that's 800 pi, plus 3, I got 2. Oh, there's no 2 there. Just pi r squared. So 3 times 100 is 300 pi. So it's 1100 pi. and the units volume, so it would be a cubic, so it would be centimeters cubed per minute.